Hello everyone. Today we are going to do a comparison on sentiment classification models on Twitter data, and we'll do comparison on different machine learning models. The presentation will be presented by us, which is Ibad, Shubham, and Tamjit. And I am Shubham. I will start the presentation. Thank you. So our main aim was we are going to do a social media platform like Twitter. We know it generates millions of posts daily, offering valuable insight into public opinion. So we are trying to do a sentimental analysis for, like, we know its opinions are really crucial, especially in brand monitoring and political insight and public health. And our main motivation is we are going to do our research is mainly motivated by the sentiment related to COVID-19, and we will be going to evaluate this data by decision tree, random forest, naive Bayes, and multi-layer perceptron (MLP). For source of our data description, we used a file name Corona NLP Train CSV. We sourced it from Kaggle. It is a popular platform for data science machine learning project. We focus on capturing public sentiment around COVID-19 through social media posts from Twitter. So our data set contains 41,157 samples, which each have a tweet related to COVID-19 pandemic. And its key features are we use a username, that which is the Twitter handle or username of the person who posted the tweet. We are not going to use directly for our analysis, but it can provide like meaningful context from what's the people name. And then there will be screen name, the display name on Twitter, like username. It helps identify the source of the tweet. And then we use location as well, the geographical location of the user. This can provide valuable insight into regional difference in sentiment, but this is not our primary focus for this analysis. And then we'll use tweet at, which is the timestamp when the tweet was posted. This can be used to analyze trends in sentiment over time, which is particularly relevant for evolving events like the pandemic. Then we have original tweet. This is the main content of each tweet, which serves as the input feature for sentiment analysis. It includes various forms of text, hashtag, emojis, and other social media specific syntax. Then we have sentiment. This is the target value variable for our classification. It labels each tweet with one of several sentiment category which we have. That is positive, negative, neutral, extremely positive, extremely negative. This serves as the ground truth for training and evaluating our machine learning models. The data include the multiple sentiment analysis, this is not uniformly distributed. Pre-elimination analysis like shows some sentiment occur more frequently than other, introducing class imbalance. This imbalance is a key factor considering in model training and evaluation, as it affects the accuracy and reliability of the model's prediction. The text data in original tweet includes a mix of natural language, text, special characters, emojis, hashtag, and URLs. This variety necessitates pre-processing to clean the text, remove unnecessary elements like stop word or URLs, and convert the words into a numerical format suitable for machine learning algorithms. And we know tweets have a character limit as well, meaning that each data sample is relatively short and concise. However, the language used can vary from formal to highly colloquial, including slang and abbreviations, adding complexity to the text processing phase. The data set is encoded in Latin 1 to handle special character present in tweet, which often contain a mix of symbols, punctuation, and multilingual content. Thank you.
Hello, this is Ibad Ahmed Siddiqui, and I'm going to talk about data set analysis, feature selection, transformation, algorithm, and model overview, including testing. So now let's begin with feature selection. For feature selection, we focused on the original tweet as the input feature and sentiment as the target variable for sentiment classification. Tweets are rich in contextual information, making them ideal for sentiment analysis. And our goal was to develop models that accurately classify the sentiments of tweet related to COVID-19. And then for text processing, we utilized essential libraries like pandas, scikit-learn, matplotlib, and seaborn. The data was cleaned and common English stop words were removed. The text was transformed into numeral vectors using the TF-IDF vectorizer, limited to the 1,000 most relevant features. And the data encoding was handled with Latin-1 encoding to resolve character issues. The TF-IDF vectorizer ensured the text data was converted into numerical form suitable for model training. And we put this snippet for text processing. In model overview, we will discuss different types of algorithms for machine learning model. Like we have decision tree classifier, random forest classifier, naive Bayes classifier, MLP, multi-layer perception classifier. So let's talk about decision tree classifier first. It is a simple interpretable model that splits data based on feature values, and it's prone to overfitting but can be mitigated through pruning. And then let's go to the next one, random forest classifier, which is an assemble method that averages prediction from multiple decision trees to improve accuracy and reduce overfitting. And then we have naive Bayes classifier. It is a probabilistic model effective for text classification, which making it a strong choice for sentiment analysis despite its independence assumption. And then lastly, we have multi-layer perception classifier. It's a neural network model with multiple layers to capture complex patterns in the data. In this slide, as I have already discussed what the decision tree model is, so we have some key features in it. The model's key feature includes its interpretability, non-linear handling, and risk of overfitting, which can be mitigated through pruning, as I told you earlier. In this project, it classifies COVID-19 related tweet sentiments using matrices like accuracy, precision, recall, and F1 score. So let's discuss about the confusion matrix. The confusion matrix shows the performance of the model by comparing the actual versus predicted classes, highlighting matrices like accuracy, precision, and recall for each class. And then the ROC curves. The ROC curves plot the true positive rate, TPR, against the false positive rate, FPR, for each class, with the area under the curve indicating the model's classification performance. A higher AUC reflects better performance. Well, I have already discussed what random forest model is before, but let's discuss about the key feature. The random forest model uses a technique called bagging to aggregate results from multiple decision trees, reducing overfitting and improving the model's robustness in sentiment classification. So the naive Bayes classifier is a probabilistic model based on Bayes' theorem, assuming that features are independent, which makes it simple and efficient for text classification tasks like sentiment analysis. This model is fast and effective, especially with large, high-dimensional datasets, and is used here to classify sentiments in COVID-19 related tweets, evaluated using matrices like accuracy, precision, recall, and F1 score. Now let's discuss about the last machine learning model, which is multi-layer uh, perceptron. It is a neural network model designed to capture complex non-linear patterns through its multiple layers, making it effective for tasks like text classification. And the key features of MLP include non-linearity through activation functions, deep learning with multiple layers, and flexibility to adapt to different input sizes and complexities. Thank you.
Hi, this is Tamjidur Rahman. I'm going to discuss the results that we got from this analysis. First of all, we have this graph that provides a visual comparison of the performance of four different machine learning models, like the decision tree, random forest, naive Bayes, and MLP across four key evaluation metrics, which are accuracy, precision, recall, and F1 score. From this graph, we can see that the random forest and multi-layer perceptron are generally the top performers. These two models consistently achieve the highest or near the highest scores across all the four metrics. This suggests that they are better at capturing the underlying patterns in the data compared to the other models. And again, we can see that the decision tree shows mixed results. While it may perform well on certain metrics, which is potentially accuracy, it might lag behind on others like the precision or recall. This could indicate that the decision tree is either overfitting or underfitting to the training data. Naive Bayes tends to the weakest model. It generally has the lowest scores across all the other metrics. This is most likely due to the strong assumptions it makes before about the feature independence, which may not hold true in the dataset. Now let's talk about the different specific metric insights. First of all, we have accuracy. All models seem to have reasonably good accuracy, with random forest and MLP slightly edging out the others. Then we have precision. Random forest and MLP again led, indicating that they make fewer false positive responses compared to the other models. Then we have recall, which has a similar trend, with random forest and MLP having a higher ability to identify the true positive cases. Then we have the F1 score. This metric balances precision and recall, and once again, random forest and MLP excel, suggesting a good overall balance between the minimizing false positive and false negatives. The performance of each model can be further improved by hyperparameter tuning and potentially gathering more data. Deeper analysis of the specific errors made by each model can provide insights into their strengths and weaknesses. So from this context, we can say that the best model ultimately depends on the specific problem and the relative importance of each of the metrics. For example, in some cases, higher recall might be critical even if it comes at the cost of a lower precision. Now let's conclude this presentation. This study demonstrates that random forest is the most effective model for sentiment classification on the COVID-19 tweet dataset, while decision tree and MLP can also be viable alternatives. The naive Bayes, though useful in some contexts, showed limitations in this scenario. Future work could involve optimizing these models further, exploring deep learning models, and utilizing additional data features for enhanced sentiment analysis. That's all from us and our group. Thank you all.